Suppose I have a box on a rough floor. So this is rough, meaning that I expect to have friction as the box moves along. Now, and suppose that I give this ball a very hard knock. I give it a knock, and the box takes off with a certain velocity. Let's say 2 meters per second. Okay, it takes off and starts moving at 2 meters per second. And let's say the mass of this ball is of this box is 0.5 kilogram. Okay, yeah. But because the ground is quite rough, this box will at first it will move at 2 meters per second, but it will quickly slow down, and then it will stop. Okay, so it will stop at some point. Now let's just say that it stops at after it has moved a distance of say 3 meters. So after sliding was 3 meters, because of the friction, it slows down and stops. Question. So wait. Okay, so here it stops. Here. The question is, what is the friction? So as it slides, as it moves, there is this opposing friction. Now let's say this friction stays the same, right? It gives the same force as the box moves. And the question is, what is this force? What is this force? So let's try and do this question. But there are two ways to do such a problem. Usually, we can either make use of the acceleration equations and calculate, say, the deceleration, and from there multiply by m using Newton's second law to find the force. Or we can also use energy and energy conservation. Now, in this example, I'm going to use energy to do this. Okay, so let me start. The idea now is to think in terms of energy. So in the beginning, it is all kinetic energy. I'll give it a knock. It takes off with this velocity. So this motion means that it has kinetic energy. But then it slows down. It has to do work against the friction. And friction is doing work on it, and that causes it to slow down. And then it stops. So when it stops, it has no more kinetic energy. That means that all of its kinetic energy, starting kinetic energy, as it slows down, must have been converted into something else. What else? Well, if the box is rubbing against the ground, then it should probably be heat. You know, when you rub two things together, they get warm. And when you rub your hands together, they can get warmer. So that's friction. That's heat. So the kinetic energy is converted to heat, and it happens because as this box moves, it has to do work against the friction. So what we can do is this. We say that the kinetic energy is used to do work. Right? The kinetic energy is used to do work against the friction. Okay, to work against friction, and this work is in turn converted into heat energy. So maybe both the ground and the box will get a bit warmer along the way. Okay, so what can we do next? So the kinetic energy here would be equal to the work done. So what I can do is I can try and calculate each of this and maybe then solve for the force. So the kinetic energy is half mv squared. We know that it's half mv squared. And the work done, we know work done is force times distance, right? So that gives us some formula to think about. And if I want to calculate this, I have to think of the numbers. So m is the mass, which is 0.5 kilogram. V is the velocity, which is 2 meters per second. Force is the unknown, okay, that we need to find. And d is the distance 3 meters. So we know everything apart except for the force. We know all the numbers, all other numbers. So this is promising. So let's go. Let's start by substituting in the numbers. Oh, it's the force that I want. Right, I'm going to do it my favorite way. Instead of putting the numbers first, I'm going to make V the subject. So let's see. So I need to get rid of the F. I'm going to divide both sides by F. So on the right hand side, I just have D left, and on the left hand side, mv squared over 2. So the F has come down here to F. So there I have a formula I can use to find D. So D is equal to, see, M is 0.5. I'm using this formula, 0.5 times V squared. V is 2. That's 2. So 2 squared divided by 2 there, and F. I just realized that okay, I need to make a correction. I just realized that I have rearranged. I've not rearranged the formula that I want. I really want to make F the subject, okay, instead of D. So I should divide both sides by D. So in this case, I have F left on the right side, and it's D that will come down to the other side. Okay, so sorry about the mistake. It happens all the time to everyone. So right, so that's a D that I need. So okay, so that's F actually that I'm trying to find, of course. So 2 times D, and D is the 3 meters. Okay, times 3. So I'm now ready to calculate the F. Let me carry on up here. F is equal to 0.5 times 2 squared. Okay, so it's half times 2 is 1 times another 2. Gives me a factor of 2 on top. Just the number 2 on top. The bottom is still 2 times 3. Now 2 and 2 I can cancel. Okay, get 1 and 1. And so therefore the answer is 1/3. 1/3. And since this is force, it's 1/3 of a Newton. And we must not forget that this is converted to heat. So according to the idea of energy conservation, okay, this amount of kinetic energy is changed into heat. So let's say now I want to find, in the next part of this exercise, I want to find what is the heat. How much heat do we get? Okay, I want to find out how much heat we get. Now the amount of heat would be equal to the work done against the friction, or it would also be equal to the kinetic energy. Okay, the energy is used to do work, and then the work produces the heat. Right? They're all equal. So therefore, if I want to find the heat, let me call heat. Q. Let me put this, use the letter Q to represent heat. So if I want to calculate heat, I can either calculate the work against friction or the KE. Now the KE formula is half mv squared. There's a squared there, which always looks a bit more complicated. But work done is just force times distance, just two numbers multiplied together. So that should be easier. So let me go the easier way. I'm going to choose to calculate the work. So let me just go back and check. I have not actually calculated the work directly yet. So let me do it here. F, I've just found that F is 1/3 of a Newton. And D is given as 3 meters. So 1/3 times 3. And therefore the answer is 1. And this is heat energy. So energy has the unit of joules. So 1 joule. Just nice.